Hey, I'm Johnny Alonso.
And I'm Jennifer Pulley.
Well, welcome to NASA 360.
Hi, I'm Jennifer Pulley. Now, when someone mentions the word NASA, what comes to mind? Space, aeronautics, astronauts, the moon, sure, all those things probably come to mind. But have you ever thought about things you use in your home every day? That's right. A lot of things that NASA originally developed for the space program are now being used in our homes today. You want me to name some? Sure. Foam mattresses, computer technology, sporting equipment, and of course that oh-so-yummy freeze-dried food. Foam mattresses and freeze-dried foods are just a few examples of the numerous inventions inspired by NASA that are being used by us today. In fact, since the beginning of the space program, nearly 8% of all the inventions in the whole world have come in some way from NASA research. One of the most successful, the cordless power tool. Check this out. When NASA started planning on how to send humans to the moon, they knew they couldn't go to the store and buy things off the shelf and send it into space. No way. They had to invent nearly everything themselves, including the spacecraft, life support systems, and of course, space tools. Everything from specialized wrenches to small handheld vacuums had to be developed. NASA's space program started in 1958. Now back then, when you needed power for a power tool, like a drill, you just found a plug and an outlet, right? Plugged it in, got power. On the moon, there's no plugs. Obviously, outlets on the moon were non-existent, so when the idea for cordless power tools came into play, NASA looked to a power tool giant for help. Any idea which company stepped up to the plate? Well, if you guessed Black & Decker, you're right. Back in the 1950s, the idea for the cordless power tool came from the Black & Decker Corporation. Alonzo Decker noticed that one of the biggest home improvement specialties of the time was aluminum storm window installation. One problem he noticed was that the workmen would rig up their power tools to an outside porch lamp, kind of like this one. And then they'd ask the housewife who was inside the home to turn on the power switch. Shocking, but true. And that worked well until more and more women began entering the workforce, leaving no one at home during the day to turn on the power for those poor men. So in 1961, after years of research and testing, Black & Decker introduced the first cordless drill, an innovation powered by self-contained battery cells. When NASA heard Black & Decker had successfully designed a cordless power system, they had to have it. The first use of cordless tools in space was the Black & Decker zero-impact wrench for the Gemini project. This wrench was great because it spun bolts in zero gravity without spinning the astronaut. Not a problem we had to worry about here on Earth. The big test was a cordless rotary hammer drill for the Apollo moon program. NASA researchers knew that they would need a very powerful drill that could operate at extreme temperatures and in zero-atmosphere conditions to take rock samples from the surface of the moon, all without connecting to a power outlet. Talk about an amazing drill. It helped bring back moon samples that researchers are still studying today. My buddy Johnny Alonso flew out to Aspen, Colorado to attend the Winter X Games. Now out there, he saw some high-flying action and he talked to some athletes who are using NASA-inspired technology in their sporting equipment.
All right, so now we know that NASA has been instrumental in changing our lives down here on Earth with power tools and such. But did you ever think that NASA might have tried to help us out with, I don't know, sporting goods? Yeah, of course they have. Check it out. During some of the most recent Olympics, NASA know-how have helped design specialized ribbed swimsuits that help swimmers get through the water faster. These swimsuits had tiny grooves that reduced drag caused by turbulence in the water. Did you know that NASA researchers actually tested pieces of swimsuits in their wind tunnels for research? Testing objects that move in the water is very similar to testing objects that move in the air. And trust me, NASA has tested virtually everything that flies in the air in its wind tunnels. So did this testing work out for our Olympic athletes? Absolutely. Our swimmers came back with more medals with just a little help from NASA. So that's how they help some of our elite athletes. But what about folks like you and me? You know, the not-so-elite athletes. Yeah, they've helped us out too. But in order to understand, you had to understand how NASA helped itself out. Back in the 80s and 90s, NASA was funding research to create new materials to be used in aerospace applications. They were looking for materials that were strong, durable, and lightweight. You know, to be used for spacecraft, aircraft, drills, man, pretty much everything. During this process of creation, a landmark discovery was made during a research project using vitrified metals. Yeah, vitrified. A vitrified metal is frozen liquid that fails to crystallize during solidification, combining properties of metal and glass not found in nature. Got it? What researchers made is something that is now called liquid metal, or also known as metallic glass. Now, liquid metal, it's an alloyed blend that is twice as strong as titanium, but softer and more elastic. This stuff's amazing. Today, liquid metal is being considered to replace titanium in medical instruments, military and aerospace applications. It's also being used in recreational equipment like tennis rackets, golf clubs, baseball bats, snowboards, and skis. So to help us check out how liquid metal is being used in sporting equipment, I came over to Aspen, Colorado, the Winter X Games. Here at the Winter X Games, amazing athletes are using some of these materials and putting them to the test on the slopes. Of course, people like me who hope to become one of those elite athletes will still use these materials as well. Check it out. I'm going to have a chat with my buddy Rex, who works for a small company called Head. Yeah, same company that builds some of the greatest equipment for some of the best athletes in the world. Oh yeah, and Rex just happens to be a two-time U.S. Extreme Free Skiing champion. Rex is going to be talking with me how liquid metal is being used in head skis and snowboards. And maybe, just maybe, he's going to give me some pointers on how to get on the podium one day. What's going on, bro?
How are you?
How you feel?
Good.
Good.
Yeah.
It's a little cold today, isn't it?
It is.
Check it out. Can you tell me something about head skis and how they're using liquid metal today?
Head skis is using liquid metal. They attach a layer of it to the load-carrying parts of this ski. It creates faster rebound. This makes the ski livelier, and it makes it livelier for longer. They also use it in golf club heads, aluminum baseball bats, things like that.
Any other companies besides Head?
Head Skis is the only ski company using this technology.
Really? So, bro, walk me through it. If you had just a conventional pair of skis compared to these new skis, what would be the difference?
The old metal in the skis has memory, so that every time you were bending it, it remembered that bend, and it would never go back to its original shape. Okay. The liquid metal doesn't do that. The liquid metal always goes back to its original shape. It's going to make it more springy off the jumps. It's going to make it faster in the gates, and it's going to make it more fun.
So it's almost like always having a new pair of skis.
It's like always having a new pair of skis. It does not break down.
And, really?
Yeah.
What's the lifeline on it? Any idea?
You know, I don't think we've found that yet. We've used it for several years now, and my skis still feel like new.
Really?
Every time.
That's awesome.
You know, the liquid metal skis are just they're gonna track more, they're gonna track better, they're gonna stay on the snow.
Okay.
Snow contact is really important. The other skis are gonna chatter a little bit more, not with liquid metal.
Really?
It's gonna be fast, rebounding right back on the snow every bump.
Let's talk about Head Skis and the company and, you know, everybody that's on board with you.
Back in the 40s, Howard Head developed a new technology to laminate different materials together, metal, wood, fiberglass, and he was the first one to do that. Before then, all the skis were just carved out of a block of wood. And so he was the first one to do that. He took his poker winnings and put it all into these 6 pairs of skis. All 6 pairs ended up breaking, but he never gave up, and he kept at it. And all skis today are based on that same principle. So he was an innovator back then. We're an innovator today with liquid metal, intelligence, all these other new technologies that nobody else has, and we're trying to stay ahead of that game. Some of our athletes now, Bodie Miller, Yoon Olsen, Johnny Mosley, those guys have input on these skis, and they're the ones, the athletes develop these skis. The company gives the public the skis that the athletes want.
Really? So they give you feedback?
They give us all feedback, yeah.
Wow, man. That's something else.
Yeah.
Well, tell me a little about the skis then. I mean, first of all, the liquid metal, where's it found in the ski?
The liquid metal in this ski is found just under the top sheet. You'll see that layer of metal right there.
This one right there?
Yep, that's it.
All the way down?
Yep.
That's awesome. So, yeah, I think most people would think that the liquid metal would be on the base or the bottom of the ski.
You know, the base is P-Tex for faster gliding. You don't really like to use metal down there, but
yeah, of course not.
yeah, you know, it would dent up, and it doesn't absorb wax.
It's not an ice skate.
And yeah, so it's on the top,
yeah.
And it's you know, one of the load-carrying pieces of this piece of technology here.
Sure.
This is in the race line, you know, it's for everyone, but this is a high-end ski.
Sure.
Yeah.
Sure. And then I guess like the not-so-elite athlete like me would be able to use something like this?
You could absolutely use something like this,
yeah.
you know. You might not want it as long as we're all using it, but
as tall as I am.
it's just going to make it easier and more fun, and,
yeah.
and you're going to have a better day on the hill.
Absolutely. Any advice to, you know, to I guess the shorties, the young kids out there?
You know, so we have all these technologies here that are developed by NASA. We're trying to make skiing safer, but you know, these technologies aren't the end all. You need to wear a helmet. You need to take lessons. You need to know your limits. You know, there needs to be a progression. You don't, just because you have these skis with all this technology in there doesn't mean that you can go out to the jumps that these guys are hitting in the X Games and be pulling the flips and stuff. You need to really be careful and learn how to do these things properly.
All right, so look, I guess you got to get back to the X Games. Rex,
Yeah.
It was good seeing you again.
Good seeing you too.
Always, and I will definitely take all of your pointers to heart, and maybe it's going to help me out on the slopes. What do you think?
We'll see. I don't know, man. I'd stick to the bunny slope if I were you. You can follow my daughter.
I put you on the show and you got to do this thing. Unbelievable. This guy. So we're wrapping up here at the X Games in Aspen, Colorado. We're going to be hitting the east side. We're going to go over to Boston, check out a cool new spacesuit from NASA. Hey, this is NASA 360. Stick around. There's a lot more to come.
Before we head back to Johnny in Cambridge, here's a question for you. What is 240 feet high? 400 feet long. And was one of the most important tools in getting those Apollo astronauts to the moon? If you're thinking, it's got to be some kind of a rocket, right? Like the Saturn V, perhaps. Well, you're absolutely wrong. While the Saturn V was important, the astronauts had to train in real-world conditions here on Earth before they landed on the moon. Where would they train for that? At this giant erector set. It used to be called the Lunar Landing Research Facility, but now it's known by people at NASA as the gantry. Back around 1965, it was determined that we needed a place to help Neil Armstrong, Buzz Aldrin, and 22 other astronauts learn how to land a spacecraft on the moon. This new state-of-the-art training facility needed to feel and look like the moon. So engineers built this large, and I'm talking 240 feet high, 400 feet long, remember? A-frame structure with an overhead suspension system. They attached a spacecraft. The pilot would train to land the craft in simulated 1/6 gravity, which is the gravity of the moon. Engineers also built a landscape that looked just like the lunar surface, with craters, dust, just about everything. All this training came in handy when Neil Armstrong, flying Apollo 11, had to take the spacecraft out of automatic mode and land manually on the moon. You see, the auto mode of the Apollo 11 spacecraft had it headed directly for a huge crater. With less than 30 seconds of fuel left, Armstrong landed the craft safely on flat ground and made history as the first person to ever step on the moon. That's one small step for man, and, well, you know the rest. Back here on Earth, what happened to the gantry after the Apollo mission? Well, some really smart people at NASA decided, I think we could use this to crash test airplanes. Yeah, crash test real airplanes for a living. Similar to how cars are crash tested to make them safer, NASA researchers basically do the same thing with airplanes, crash dummies and all. What they do is hook up an airplane to a large steel cable and swing it like a pendulum down to the ground and test how the plane handled the crash. What they found was that many of the crashes that seemed survivable were not. The planes looked to be in pretty good shape, but sensors embedded in the crash test dummies showed the occupants wouldn't have survived. That really stinks for you guys, but it's great news for all of us who fly on airplanes. Because of this research, NASA figured out ways to build airframes and aircraft seats to keep more people around in case of an accident. After, they sent these recommendations on to airplane manufacturers. Changes were made to incorporate these life-saving improvements. All right, now that NASA is planning to go back to the moon and send humans onto Mars, do you think they're still using the gantry for training? Of course they are. In fact, they are currently testing a new crew exploration vehicle. It's called Orion. And it's really exciting. So how will NASA use the old gantry on their new mission back to the moon and Mars? Before the space shuttle, astronauts used to arrive home by splashing into the ocean. Well, Orion might use that same idea. Or they may land in a desert in California using parachutes and good old airbags.
Researchers at the gantry have been testing the bottom outer shell of the Orion spacecraft to see how the airbags perform on land. Researchers placed dirt that is very similar to the dirt in California and spread it out over the gantry floor. Then they swung the test vehicle up and released it.
Looks like the old gantry is still pulling its weight after all these years. And you know, NASA isn't just planning on going back to the moon one day. Oh, they're planning on sending humans to Mars.
This is going to be a completely different type of mission, never done before. So we have to develop tons of new technology to get us there. New spacecrafts to different types of food preparation and even new spacesuits.
Well, it's time to head back out to Johnny Alonso. He's in Cambridge, Massachusetts, learning about how these cool new spacesuits are going to work.
Hey, do you remember earlier in the program when I showed you a picture of an astronaut with this huge cordless power drill? Now that drill was actually pretty hard to handle because of the way the spacesuit was designed. Now those suits were the cutting edge back in the 1960s, yet astronauts still lacked the mobility they really needed. Future missions to places like Mars will require us to develop new types of spacesuits that not only keep our crew safe, but can allow astronauts increased mobility, just like they were working out in their own backyard. I came here to Cambridge, Mass. to speak with MIT professor Dava Newman. Her team is designing a new type of spacesuit that's going to be super effective and way comfortable for our astronauts. Hey, another great thing about this suit, might have some benefits for people back here on Earth.
We're here at the Manned Vehicle Lab at MIT with Dr. David Newman. Doctor, thank you for coming on the show.
Thanks, Johnny. It's a pleasure to be here.
Thanks. So, tell me a little about what you guys are doing here.
So we specialize in looking at astronaut performance for both microgravity, the moon, Mars. We'll be able to talk to you today about some of our work in advanced spacesuit design. We're trying to design a suit actually to get astronauts to Mars. So it's a pretty futuristic looking concept. We call it the biosuit. We call it a second skin. You have to apply pressure to keep the astronauts alive. So in the current suit, that's like a balloon. You're operating inside a balloon. It's called the extravehicular mobility unit. Very massive suit, very heavy. It's about 140 kilos now. Now we're in Space Shuttle or on the International Space Station. It's weightlessness. So the astronauts don't feel the mass of the suit. They can work in it. It's great to do Hubble Space Telescope repairs. But when we get to the moon and Mars, we need a locomotion suit. So a lot of our research is geared to how do we provide astronauts with maximum mobility and minimum energy requirements. We want them to be able to go out and be productive and work for a long time. So that's what you'll see in the biosuit. The huge advantages are then we can aim for maximum mobility. Much more like wearing clothes than it is operating in a big gas pressurized shell. Some of the advantages we have for the biosuit is we can have a really lightweight suit. When we get to the moon and Mars, our astronauts are going to be kneeling down and climbing and doing some really extreme tests. So we need to provide maximum mobility. And then finally, safety reasons. If, let's say, you get a little tear, you're working on your knees and you get a little tear in the suit, we envision then you just put another layer on. You just wrap it up. Another layer of mechanical counterpressure. You just keep doing your business. You keep doing the science and experiments.
So you can repair the suit, I mean,
we think so. It depends. If we can get, millimeter by millimeter, kind of small, you can't have a big gaping rip, of course. You have to always pressurize the astronaut explorer. But for a scuff or just a scratch, we think we could just put a quick bandage on it, literally. So some of the design concepts that we've incorporated into this mock-up, the black lines that you see are something we call lines of non-extension. If you move your skin in your arm and you move around, we want to, again, get maximum mobility. So it turns out if we have to carry the pressure, again, you want to pressurize the person and attain maximum mobility. So the black lines have a lot to do with trying to achieve that, holding the constant pressure while providing maximum mobility. The gold lines that you see all over the suit, they kind of follow major muscle groups for thermal control to make sure that you're providing enough heat. And so you would just weave that in. The idea is you just weave that in and get thermal control, would sense the astronaut's temperature and heat them up if necessary or perhaps cool them down.
So how does it help astronauts on other planets?
So you can imagine if we can put here in the knee joint something that helps someone walk. When the astronauts get to Mars, they might have gone through a lot of physiological deconditioning. So you might have to assist their locomotion, probably in the first month until they really regain their muscle strength back. They might have a loss of about 40% muscle strength loss, 20 to 30% muscle atrophy. So if we can give them some assisted locomotion, that will really help, say, on early arrival to planets. It's a very expensive mission. We want to send people there, but when you get there, you can't take a month off. You need to work almost immediately. So we need to hopefully embed some of these enhancements, technological enhancements, kind of where the human and the robot come together in future suits. One of our 1G and medical benefits of some of our research are to think about helping people with disease on Earth.
Okay.
For instance, like locomotion. We really like to help people walk. We think about how our astronauts are going to walk on the Moon and Mars, but there's a lot of people here, of course, on Earth that we'd like to help. So we look at some disabilities for stroke, cerebral palsy, multiple sclerosis, and we think of assisting that locomotion. So our designs help in that sense. We've had one project that's assisted locomotion, basically putting a power assist on a leg. For instance, a stroke patient usually is affected asymmetrical. So you might have the right side of your body that's working well, but for locomotion, your left side might not work so well. So we can take a look at the left leg then and try to give it a bit of a kick, if you will, to help the locomotion. You can take signals from the right side of the leg that's working perfectly and get the same ankle, knee angle, instantaneously get those to the left leg, and then have the right and left leg work together. Other applications for 1G that are found for extreme sports or athletics, you can imagine, helping people maybe jump higher, run faster, things like that. So that's where some of our robotics technology kind of embedded into some of these designs for the future. We'd like to pursue some of that research.
We're going to take a short break. We'll be right back. You're watching NASA 360.
This is our latest biosuit mock-up.
Cool.
We've worked with businesses here in the U.S., Charting Associates, and with some Italian designers, Dainese. It is skin tight. This is just a mock-up that kind of has the look and the feel of what the skin suit might look like in the future. So I can kind of demonstrate the mobility. It's really easy to bend down. I probably spend a lot of time, doing research and the Moon and Mars in these kind of configurations. And the trick to mechanical counterpressure is if we put it on and it's pretty comfortable, then we want the ability to, while it's on, to be able to kind of cinch it up, get that final pressure production.
It's right there.
Right, so we can kind of show you a little demonstration. This is just a little mechanical system we're thinking about, but you can kind of see it cinching up, and sure enough, if I get it really tight here, it kind of applies more pressure.
Is it comfortable?
It's really comfortable.
Yeah?
Yeah. It's nice and warm.
Yeah.
It's nice and warm. I can show you with the helmet on. People don't think it looks like a spacesuit until you put the helmet on.
That's cool.
Right. Put that on. Need gold sunglasses in space.
Where'd you go?
There you go.
Something else. You look great. Seriously.
Thanks. You want one? We'll get you.
Absolutely.
All right.
You'll supply the shop anyway.
Okay.
Listen, nice to meet you, Dr.
Very nice to meet
Thanks
you.
for that MIT over here. So this is NASA 360. We're out. As you can see, NASA technology and inventions are not just for space travelers. They help all of us every day. Just take a look around your house. There are dozens of things that are inspired by NASA technology. And you can bet, with NASA's new push to go back to the Moon and Mars, that tons of stuff is going to be developed to help our lives back here on Earth. All right, that's it for now. Thanks for joining us. I'm Johnny Alonzo. Check you next time on NASA 360.